So the first question that's asked, and I could ask you all kinds of things here. Just understand this about this question. I could ask you about how many positive solutions are possible, how many negative solutions are possible. I could ask you to list the possible rational zeros, right? If I asked you about the positive and negative solutions, you'd have to go to Descartes' rule of signs, okay? And in fact, let's just look at the Descartes' rule of signs real quick. The number of positive solutions, how many are there? Well, this is positive, so that's not a sign change. This is positive, that's negative, so that's one sign change. Then we got negative, 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 positive, so that's two sign changes. So in terms of positive solutions, there will either be two or there'll be none. Does that make sense? If we do negative solutions, you replace x with negative x. And what happens? A negative number raised to a positive or to an even power, this piece will stay positive. A negative number raised to an odd power, this piece will become a negative sign. A negative sign raised to a positive or an even number makes that positive, so this one will stay negative. This one will become positive, and this one will stay positive. Does that make sense to everybody? Changing x with negative x. This one won't change. This one will. This one won't. This one will, and this one won't. Now count the sign changes. 1, 2. So the number of negative solutions are 2 or 0. Okay? Yes?
I don't understand why some change.
So if it's raised to an even power, it won't change the sign of the expression of that term. If it's raised to an odd power, it will.
Okay, I understand.
So even numbers won't change, odd numbers will. Even won't change, odd number will.
I wasn't thinking of the whole exponent being replaced.
Yeah. All right. Now, all right. So possible zeros, what are they? Well, they're factors of 30 and 1. Do we agree? So it's the factors of 30 and the factors of 1. So your options are 1, 2, 3, 5, 6, 10, 30. 15. 15's in there somewhere as well. All right. So what number do you want to try?
3. Wait, what? 1.
I'd try 1.
So you can just switch them around when you want?
What do you mean?
Because the last time we took the factors of the first exponent and we found out the second.
No, we took factors of 30 over factors of 1. It's always the last number on top, first number on the bottom. So the possible zeros are plus or minus 1, 2, 3, 5, 6, 10, 15, and 30. Those are the possible zeros. And that could be a question just as easily, right? Like, hey, what are they? And you just got to write them out. Let's try 1. Let's see if 1 is a 0. 1, 3, negative 15, negative 19, and 30. 1 times 1 is 1. This is 4. This is 4. This is negative 11. This is negative 11. This is negative 30. This is negative 30, and this is 0. Okay. I apologize because that was pretty fast and zero explanation whatsoever. Drop down the first number and then multiply. 1 times 1 is 1. Then that goes here. 3 plus 1 is 4. And then you multiply 1 times 4, and that goes here. Negative 15 plus 4 is negative 11. 1 times negative 11 is negative 11, and that goes there. So forth and so on. Now, when we know that x equals 1 is a 0, then what do we know? Well, there's got to be a second one. Because remember, what we said was either there's 2 or there's none, and now that we found 1, we've ruled out none. Does that make sense? So now there's got to be a second one, and it's not going to be 1. So what number do you want to try now? I don't know, 2.
1 is one of the answers, right?
Yes, 1 is one of the answers for sure. So now you take this line and you try another number. So let's try 2. We'll see if 2 works. 2 times 1 is 2. This is 6. This is 12. This is 1. That ain't going to work. Do we agree? Because you got to get to 30, and that ain't going to happen. Does that make sense? Let's try 3. This is 3. This is 7. This is 21. This is 10. This is 30. And so 3 works. Does that make sense? So now we don't have to try any more positive numbers because we got 1 and 3 and they both work. At this point, we started off with x to the 4th. Then we got x to the 3rd. This will be x squared, yes? So at that point, you might be able to write it out like this and just go ahead and finish. X plus 5, x plus 2, and you don't have to go through the synthetic division anymore. Okay? If you were going to continue with the synthetic division, I would try negative 2 as your next number. Just my guess. Okay? So what we have here is that this piece, has 3 zeros. They are x equals 1, x equals 3, x equals negative 2, and x equals negative 5. Do we agree? Here's another question I could ask. How do you factor it? How would you factor that? I got an idea, I'll tell you. If each one of these is a 0, then that meant that this piece started out as x minus 1. Does that make sense? This piece started out as x minus 3. This piece started out as x plus 2, and this piece started out as x plus 5. Do we agree? So what I can say is that f of x is equal to x minus 1, x minus 3, x plus 2, and x plus 5. Does that make sense? And now, additionally, what I can say is, because now the next question asked what? When is f of x greater than 0? Isn't that what it asked? If I have the factored form, what do I know? It's x to the 4th, so that means it goes up on both sides. Do we agree? So the end behavior is it's got to go up here and it's got to go up here. Now, where does it cross the x-axis? Who can tell me? Where does it cross the x-axis? Go ahead.
1, 3, negative 5,
Negative 5,
negative 3.
negative 2, 1, and 3. Do we agree? When it leaves 3, it's got to go where? Up, right? When it leaves negative 5, it's got to go where? When it leaves negative 5, it's got to go. Oh, shucks. It's got to go up, yes? Does it pass through -5 or does it reflect? Who remembers? Why?
Because it's I, the exponent is 1.
Because my calculator says it passes through, damn it. If it's odd, it will pass through. If it's even, it will reflect. All of these are odd, so all of these pass through. Down, up, down, up. Now, what I don't know is how high does it go? I mean, I don't know if it's a little hump like this or if it goes up like this. For the purpose of our discussion, it doesn't make a whole lot of difference anyway. What's that? The exponent. The exponent. Okay. My guess is these humps are much more conservative than what I'm showing them to be. Okay. When's it greater than 0? Negative infinity to -5. Union. -2 to 1. Union. 3 to infinity. Okay. When is f of x less than or equal to 0? -5 to -2. Union 1 to 3. Does that make sense? We good? Now, any questions on that? There's a lot of stuff there. I mean, there's a lot of different questions that could come up, all of which will be on a test, by the way. So on a test, you're going to have probably one question that's going to have multiple questions attached to it. How many possible zeros are there? How many possible negative zeros are there? What are they? What are the possible zeros? So forth and so on. Yes?
For the -2 and -5, how did you get those numbers?
You mean originally?
Yeah.
So the question was, how did I get -2 and -5 originally? Once I got it down to here, and I observed that this is x squared plus 7x plus 10, I went ahead and factored it. If not, you'd have to go back to using synthetic division. I'd try -1. If that doesn't work, I'd try -2, and then it would work, and then that would lead you to the final answer. Okay? Any questions on that? I mean, again, please ask. This is the time to ask. Because what I don't want you to do is get to the test and go like this. Dang, wish I had asked. Okay. Going once. Going twice. All right, what does the next one say? Next one says f of x equals 2x to the 4th minus x cubed plus 7x squared minus 4x minus 4. And we know that x equals 2y is the 0. Do we agree? If x equals 2y is a 0, there's a couple ways to handle this problem, by the way. There's several ways to do this, which never makes anybody feel better who don't know how to do it, by the way. Like, hey, there's a lot of ways to do this, and you're like, great, I don't know any of them. But one way to do it is to, if x equals 2y is a solution, what other solution do we know has to be there? not necessarily. Although there's got to be a positive solution, because if you look at Descartes' rule of signs, this is one sign change, two sign changes, three sign changes, and then it doesn't. So the number of positive solutions has to either be 3 or 1. So that tells me that there's got to be at least one positive answer. If I told you that I did the quadratic formula and one of the answers was 8 minus 3i over 5, what would an additional answer be, you think? Wouldn't it be 8 plus 3i over 5? Doesn't this, when you do the quadratic formula, isn't that always plus or minus the square root? And so that if you got an I as one answer, you'd have to get the negative I as the other answer. Okay? That's the idea here. That if x equals 2i as a solution, x equals negative 2i must also be a solution then. Now, how do I use that information? Because some people go like this. Yeah, okay, fine. I mean, I believe you now. I don't know what to do with it. Well, there's two ways to do it. Number one is just go synthetic division on this thing. Now, synthetic division on it's going to be a little bit harder. Does that make sense? Because you're going to end up with a bunch of real and complex portions of it that's going to be kind of screwy. But it would look like this. 2i times 2 is 4i. And then when we add straight down, we get negative 1 plus 4i. And this is where things start going hairy. Does that make sense? Because now you got to do 2i times this. And 2i times negative 1 plus 4i. That would be negative 2i plus 8i squared. So that would be negative 8 minus 2i. Does that make sense? Which when you add straight down, you would get negative 1 minus 2i. And now you got to multiply 2i times this. So does everybody see what I mean? It gets kind of jumbled. Does that make sense? If you do it that way, it gets kind of, and it's a completely effective solution. You do 2i times negative 1 minus 2i, negative 2i. This becomes minus 4i squared, so this becomes 4 minus 2i. Then when you add straight down, you get negative 2i, and 2i times negative 2i is negative 4i squared, which is positive 4, right? And then from there, you would do negative 2i again, and you would ultimately get the same basic thing. Does that make sense? But what would be an alternative? What would be an alternative? If x equals 2i is a solution, and x equals negative 2i is a solution, wouldn't this be x minus 2i? X plus 2i, if you wrote them as factors the way we did the last one. See, when I got x equals 5, I got x equals negative 2. I wrote them as factors as x minus 5, x plus 2. Does that make sense? So if these two are zeros, then the factor would look like this. Is that right? If I multiply that out, what do I get? X squared plus 2ix minus 2ix becomes what? 0. Negative 2i plus 2i is what? Negative 2i times 2i becomes what? Negative 4i squared, which is 4. Do we agree? So we know that x squared plus 4 is a 0. We know that x squared plus 4 is a 0, yes? So what do we know? That this can be written as x squared plus 4 times something, yes? What would this piece be? And how would you find it?
2x squared.
I agree it would be 2x squared. I think we all agree it's 2x squared. It's this last piece, and people are going like this, and that last number better be -1. Right? Because 4 times -1's got to be -4. How would we do it? What would be the more precise way other than just looking at it and trying to guess? What could we do? Who remembers when I showed you long division? Who remembers when they solved long division, you swore you would never need it again? Okay. You actually, it's very useful here. X squared goes into 2x to the 4th. 2x squared. You get 2x to the 4th plus 4x squared. Do we agree? When we subtract, we change this sign, we change this sign. Adding straight down, what do I get? Negative x cubed. This becomes 7x squared minus, wait, this should be 8x squared, yes? This is plus 8x squared. My mistake. When you multiply this times this piece, you get 2x to the 4th. And then you get 8x squared. And when you subtract, this becomes a negative sign. And that's just negative x squared, yes? X squared goes into negative x cubed how many times? X squared goes into negative x cubed how many times? Negative x times. So you'll get negative x cubed minus 4x. When you subtract, this becomes positive, this becomes positive. These cancel, you get negative x squared minus 4. X squared goes into negative x squared how many times? -1. Negative x squared minus 4. And then they cancel. So this piece becomes 2x squared minus x minus 1. So simply, and I say simply, and it is not simple at all. If you know an imaginary zero, if you know, and I'll go back to that previous screen, just give me 1 second. If you know an imaginary zero, you know a second imaginary zero by default. How you deal with those two imaginary zeros to get that remaining piece is the issue. If you do synthetic division, what you'll end up with is simply this piece right here, 2, -1, -1. That would be the final portion of that synthetic division for the second half. Okay? What do you do once you get to here? Once you have it factored like this, what do you do? Did you say it? Yeah, then you'd be able to factor it. That would be 2x plus 1x minus 1. Okay? Once you got to here, see, once you get to here, once you get to there, then you would say x squared plus 4, 2x plus 1, x minus 1, yes? Which means x equals 1 and x equals negative 1/2. Okay. Which, by the way, goes in line with what we saw when we said that there was one, when we looked at Descartes' rule of signs and we said there was a positive solution. There is one. It's this one right here. So the zeros are 2i, negative 2i, negative 1/2, and 1. Does that make sense? What I'd like to do is, I'm going to put the video on hold. I would like to do another one like that, because if you haven't done the homework, you've never seen that problem before. Okay, and it's certainly not fair for me to assume that just because I come here and show you how to do it, that you leave going like this. Oh, piece of cake. That's so easy. All right, now you need to have seen it and tried it on your own, having an idea what it is you're supposed to try to do. But before I do that, I want to give you this. I want to see if you can do this. I want you to write f of x. I'm not going to tell you what to put here, but here's what I want to tell you. I want the minimum degree possible where the zeros are x equals 3, x equals negative 1, and x equals 4/5. I want to see if you can write a polynomial, f of x, where the zeros are x equals 3, x equals negative 1, and x equals 4/5. Go. Write it out. Write the expression, please. Uh-huh. Oh, shoot. My bad, people. Hope you fast forwarded it. What would the polynomial be? Well, if x equals 3 is a 0, then we know it has to start with x minus 3. If x equals negative 1 is a 0, then there's got to be a factor of x plus 1. If x equals 4/5 is a 0, this one's harder. What would this piece have to be? 5x minus 4. Do we agree? Now, the reason why I say minimum degree whose zeros are 3, negative 1, 4/5 is because technically, hell, you could raise these to any power you want to, and it would still have zeros of those things. Does that make sense? So by saying minimum degree, meaning I want each one of them to be a 0 of 1. Additionally, never mind. Okay. Now, could you leave it like that? You know, taking Pletcher you could. But no, let's multiply that thing out. X minus 3, x plus 1. X squared minus 2x minus 3. Do we agree? Times 5x minus 4. Do I need to show everybody how to multiply this out, or can I just tell you what the answer is? Well, I can't do it, but I was just asking. I mean, it's 5x cubed minus 4 minus 10 minus 14x squared minus 15 plus 8 is minus 7x plus 12, approximately, if I multiply that out correctly, and I'm pretty sure I did. Okay. We good on that? What the heck is he saying? All right. P of x equals x to the 4th minus 2x cubed minus 6x squared plus 22x minus 15. That's a 15, not a B. A 0 is 2 plus I. 2 plus I is a 0. 2 plus I is a 0. You find the other ones. There are 4. You find all 4. Go. All right. So, as a different side note, there's a question that just was approached, which was, what are the i's? I to the 1st is I. I to the 2nd is negative 1. I to the 3rd is negative I. And I to the 4th is 1. Reminding you that if we had I to the 29th, the way we would simplify that is 29 divided by 4, 7, remainder is 1, and this is the number we look at. If the remainder is 1, it's I. Remainder of 2, it's negative 1. Remainder of 3, it's negative I. If the remainder were 0, that's the same thing as 4. Okay? Obviously, I to the 0 power is 1. Because anything raised to the 0 power is 1. Okay? So that's the I stuff. Now, if we have 2 plus I, what other number do we know for sure has to be a 0? 2 minus I. So what do we know? What are the factors then? X minus this piece x minus this piece and x minus this piece. Do we all agree? Now, this becomes x minus 2 minus I times x minus 2 plus I. Do we agree? Now, when we have to multiply this out, a lot of people don't know how to do that. There's actually a trick to be invoked. And if you see the trick, you do it in your head. If you don't see the trick, you can't do it in your head. Okay? And here's the trick. If I look at this as the difference of two squares, you see, if this were x plus 3, x minus 3, I think we all agree we can do that in our head. It's x squared minus 9. Does that make sense? And when I see this problem, that's what I see. I see that because this piece and this piece are the same. The only thing that's different is this, and they're different by a sign. Does that make sense? So for me to do this, because one of my great skills in life is to take something like this and go, oh, that's x squared minus 4x plus 5, and people go like this, man, get the hell out of here. Well, no, it is because this is x minus 2. This is x minus 2 squared minus I plus I is minus I squared, and that's all you got to really do. Does that make sense? Just like this is x squared minus 9, this is x minus 2 squared minus I squared. And so I know that that is x squared minus 4x plus 4 minus I squared is negative 1, and that's where the 5 comes from. That's a very subtle trick that will save yourself a whole lot of multiplication, because my guess is most of you who got to here would have gone x times x is x squared, x times negative 2 is negative 2x, plus ix, and then gone through the whole thing. Okay? And there's nothing wrong with that. It's just that's a little quicker if you can see it that way. So what do we know? What we know is that x squared minus 4x plus 5 is a 0, or a factor, excuse me. X squared minus 4x plus 5 is a factor. What's this other piece right here? Right now there's people going like this. I bet you it's got an x squared in it. Thank you, Captain Obvious. Other people go like this. I bet you it ends in negative 3. Again, great observation. Right? We know it's got to be x squared. We know it's got to end in negative 3 because that's how you're going to get x to the 4th and negative 15. That middle number right there, all bets are off. So what do? You just divide it. X squared minus 4x plus 5 goes into, what was the expression? I don't even remember. X to the 4th minus 2x cubed minus 6x squared plus 22x minus 15, yes? Just go away. All right. What is it? It's x squared. This is x to the 4th minus 4x cubed plus 5x squared. When you subtract This becomes negative, this becomes positive, this becomes negative. You'll get 2x cubed minus 11x squared plus 22x. X squared goes into 2x cubed how many times? 2x. You'll get 2x cubed minus 8x squared plus 10x. Subtract. This becomes negative, this becomes positive, this becomes negative. Negative 3x squared plus 12x minus 15. X squared goes to negative 3x squared, negative 3 times. Where at, buddy?
Negative 6x plus 5x squared. Instead of 11.
No, it's not. It was plus originally, and then when I subtracted, you got to change the sign to a minus. So it's negative 3x squared plus 12x minus 15. When you subtract, all of these change signs, and everything will cancel. Okay. So x squared plus 2x minus 3 becomes that other factor that we were looking for. Does that make sense? This piece becomes the other factor that goes into here. X squared, whatever I said it was, plus 2x minus 3. And then once you get this piece and this piece, you'd be able to continue. Any questions on that?